Today's video will explain how to design with a large inheritance tree. Hello, I'm James Helfrich. We often find ourselves working with a large inheritance tree. That is, an inheritance tree with a large depth. And some people say that these large inheritance trees are unwieldy and difficult to work with. This video will explain a couple techniques we can use to keep the design of the inheritance tree aligned with the problem domain and to make sure that it is easy to work with. Special challenges arise when working with large inheritance trees. Though they have a reputation for being unmanageable, it is possible to effectively negotiate their pitfalls with a few simple strategies. Now, an example of a very large inheritance tree, which was well defined, is a taxonomy of living things. A 7-layer design captures about 10 million distinct living things. So the animal kingdom, and there's 6 kingdoms, and then we have phyla, and there's 21 phyla. And then after that, we have the class, and we happen to be Mammalia. And then there's the order, we happen to be primates, and then a family, and then the genus, we're Homo, and there's 500,000 genera, and then there's 10 million species. And so here we have 10 million different elements in this large inheritance tree, but they're manageable. Well, let's see why that is. First of all, in the taxonomy of living things, none of the categories or divisions are arbitrary. Each represents a meaningful distinction between groups of organisms, and all the members contained in each group share a common characteristic. For an example, all members of the Animalia kingdom share the same characteristic. They can move, consume oxygen, and eat. Not only is it easy to classify a living thing as an animal, but it's also easy for a non-biologist to recognize an animal. And each of the following are animals with spinal cords. So here's a best practice. Every base class should map to a design concern. So this graph shows a number of species associated with a given genre. On one extreme, there are 338 genera with exactly one species. It is the most common by far. And then there's exactly 176 genera that have 2 species. And there are 105 genera that have exactly 3 species. And then there is 27 genera that have more than 50 species associated with them. So what does this mean? Is that the inheritance tree is highly imbalanced. There are some genera that have many species and some that do not, but that is not an important design concern. Do not worry about balancing an inheritance tree. It's far more important that it aligns with the problem domain. There's a curious feature in the taxonomy of living things. There's only 3 species of elephants, and yet there are 500,000 beetles. So we have the order, family, genus, and species. Now, for the elephants, I can't even pronounce that. But for the beetles, there's this. Now, for the elephants, there's exactly 1 family. For the beetles, there's going to be 21 families. For the elephants, there's going to be 1 genus. For the beetles, there's going to be 6,800 genera. And there's exactly 3 species for the elephants, but there is going to be 225 other species for this genre in the family. And so in other words, there's a huge imbalance between number of elephants and number of beetles. And yet, but we still think it's useful to have an order that has only 1 family, a family that has only 1 genus, and a genus that has only 3 species. So a well-designed inheritance tree should seek to make level distinctions consistent across branches. And each one of these should map to design concerns. So a best practice, each level in an inheritance hierarchy should mean something. When an inheritance tree can have duplicates, redundant, or unused classes, all of which should be avoided, having too few can often result in missing functionality. There is a practical limit to the size of an inheritance tree, the capacity of a programmer to internalize the design. So seldom should you create an inheritance hierarchy deeper than 3 or 4 levels. So here's our best practice. Keep the depth of the inheritance tree reasonable. That being said, sometimes the problem domain is so large that we're forced to use more than 3 levels or 4 levels. The meaning of every division in an inheritance tree should be unambiguously communicated to all. So here are 2 additional best practices. Unambiguously communicate the meaning of each division in an inheritance tree, usually with a big fat comment at the base class. And choose base class names carefully, and that base class name should reflect what that division means. You can learn more about this in the Large Inheritance Tree chapter of the Software Design textbook.